I see Sangamesh has raised a hand. Sangamesh, you can unmute yourself, and if you want to, say something, or if you have anything to share, you can go ahead. Hello, ma'am. Are we good to go? I think it's 11:02, and we're hitting around 120 participants. So if you want me to give a couple of more minutes, so I'll be happy to do that. Hello. Uh, Anyone from Kaylee team? Guys need a confirmation whether we can begin or not. All right. I think we can begin. I'm seeing in the message coming in from the KV team as well. So, yep. Good morning, guys. And I think we're good to go. Let me share the screen. Um, all right. So here we go. You guys able to see my screen? Okay. Uh, so in this particular session, so I'll be mainly focusing in on the four aspects which we have over here. So the first one is with how we basically use AI to fight this battle in which we are with COVID-19 currently. And the second one is the usability. We might have a great and a superb idea, but how that idea is actually uh, viable, or how is it even achievable in terms of cost, in terms of implementation, and will it even work? So the third part will be on the ground level reality, like the idea looks good, the implementation is also great, but the response it gets and the implementation part of the same idea is failing up at the ground level. And the last part is what next, and how the world as we know is going to change because of this pandemic, in a good way or in a bad way. And the last part would be for any kind of extra Q&A which will be opening up. But what I personally encourage and strongly believe is, you guys can go ahead and raise up the questions when and where we are going through, um, and we will get back on that and we'll clarify. Okay, so the first part is with respect to the fighting phase along with COVID. So with all the news coverage and the current day scenario in which we are, so we have heard a lot and we have known a lot about the existing pandemic which is there, and where it originated, and how it is actually spreading across the world, and what are its ill effects. But in this particular slide, I would like to emphasize on the other aspects which are kind of not emphasized more upon, and what kind of a ripple effect will this pandemic have on multiple domains which we have. So the first one and the important one is loss of life. uh, so we all know that it is a Sark family virus, which has mutated, and it's originated from bats, and it is having a little limited mortality rate when compared to that of the other pandemics like the flu, or the which we call the Spanish flu, or even the plague for that matter of fact. That is due to the technical advancement which we have, and due to the zeroing in on the existing patients and treating them up. So the second one of that would be on the moral and the social breakdown. Uh, so we, as a individual or as a human being, are bound to carry out our work and uh, you know go up with our normal lives and have a normal family. But due to the pandemic and because of the lockdown of uh, one of a kind of in the history, so most of the people are not capable enough to actually cope up with the current day scenario, and most of them end up with uh, breakdowns, that is on a social ground or on a moral ground. And it is one of the reasons why we see the rate of suicides also going in, and the recent suicide of Sushant Singh Rajput, which can be associated with it. So the more time you give yourself and in isolation, the more mental stress you are going to develop, and that is how it's gonna impact on the longer run. The third one is on the economic blow. So basically, all of you know, like most of you guys might be even getting paid half the salary, or asked to pay the fee of your kid, or anything in that particular matter of fact. And as a country and as the from the world's perspective, we are undergoing a economic slowdown because of the uh, drop in the production industries, drop in the manufacturing industries, and so on. So that is with the economical aspect. So in the list, I would say economical aspect would be the one which we need to consider with a little less priority when compared with that of the other ones, because as they say, "Jaan hai to jahan hai." So if you have your life, then all these materialistic things can be achieved, and you can go through with that. And then the biggest problem which we faced, and which received a lot of media coverage, was with the large migrations or the biggest exodus of the current world which we know of. Due to the pandemics, the jobs actually dried out, and the daily wage workers, or the individuals who actually depend on uh, their day-to-day labor, and which who are getting paid on a daily basis, they tend to move out to their natives. So the larger migration on the pattern which we saw was also huge. So basically this kind of results in multiple zombie cities. There's a one news coverage on one of the cities near to Noida, where nearly 1.5 lakh apartments and the buildings are left vacated, and all the people or the inhabitants who are there have been moved out, and they're back to their natives. So it is kind of draining out of human resources from your core cities or the metropolitan cities, and that is how it is having another impact on the society as we know it. Um, the other one is the major blow to how the world worked before the pandemic, and how the world is going to adapt after this pandemic. So we all enjoyed the street food and all the various tastes on the of the Indian cuisines. So going forward, most of them will be controlled and contained. We are not gonna go back to the same good old days where we used to enjoy all the street food and the other stuff. It will come back after a year or a year and a half, but that's a bigger blow. And when it comes down to the working styles, as you all know, most of you guys might be faculty members, so you will be knowing in what is the exact hard time which the individuals are going through to adapt to the existing changes in the world, because not everyone in India are ready for the internet boom, and they're not well adapted for their complete work environment and their complete work to be migrated to online. And that's the fact that we cannot automate, or we cannot take the complete working onto the online platform, because at some point in time it needs to be delegated, and it needs to trickle down onto the humane aspect as well. So the other important things which we learned is, like, no matter how technically advanced you are, no matter if you are on top of the food chain, or if you had that kind of a superiority feeling, with a single whip from the nature's side, everything actually moved out, and we are back to the good old days where we are kind of trying to protect ourselves and the protective instincts. So that kind of humbled the human race, which I believe, with all the technical advancement and all the pollution and the extortions on top of the existing natural resources which we were doing, took a backseat. That's an advantage of this particular pandemic. So that's the reason why we are seeing more clear skies, fresh waters, and the rarest of the species coming out on surface. So most of you guys have heard about this in the social media, and that's one of the biggest influencing part. So so the second part is with respect to how unprepared we were and how off guard we were caught when this pandemic actually hit us, and how can we position ourselves in a much better way so that we can tackle this particular pandemic, and we can uh, decrease the mortality rate as slow as possible. So the last part is with respect to how the existing tools which we have are lending a helping hand to fight against the situation in which we are. So this is where the whole crux of the issue actually gets started, and this is how we can get into the deep roots of the issue, and whatever the things which we have in our hand, and how can we go ahead and use the same or recycle it to fight the existing pandemic in hand. So in this particular presentation, I would be mainly focusing on these particular aspects. So the first one is the vaccine development and the clinical trials, and how AI is aiding in all the existing ones. So the first one is with the vaccine development and the clinical trials. So I've chosen the names to be self-explanatory, but we'll be digging deep onto each of these concepts, and we will be validating how AI is gonna help us on this. The next part is with the infection spread. So this basically also deals with the containment of the you know uh, the positive tested individuals, and how we are going to uh, control the spread of the disease further. The next one would be with the diagnosis and the treatment. Um, so as we know that the doctors and the police officers are the frontline workers, and also the ASHA workers which we have are actually laying down their lives and their livelihood to actually help us win on this particular pandemic. Big thanks to them on this platform as well. So the next one is with respect to the post treatment and the insurance care. So after the individual has recovered, so it's not just the end of the road over there. So there are different set of challenges which actually repost themselves, like what should be the next steps and how we're supposed to go through with that. So we'll be dealing with that. And the next part is with respect to the authority data collection and the planning for further pandemics, or kind of yep. I think it's Sapna Gupta. Hey Sapna, do you have anything? Okay, so just unmute.
No, no, stay.
Yep. Okay. So, so the next part would be with researchers who are actually going ahead with the analysis of the um, disease, and how we are going to go through with the impact and the medical advancements which we have, and how the individuals can also use and who are using AI directly or indirectly for kind of saving themselves as well as protecting the others around them. So the last part would be with individual tracking and risk analysis. So there's no surprise on this one because of the whole worldwide spread of the disease. So we need to come up with our own steps so that we can track the individuals who are actually showing symptoms, and try to contain them. So that is the biggest approach which we can do, and within our power. So we'll be dealing up with our own homegrown app, Arogya Setu, on this particular aspect. Okay, so the first part is with respect to the vaccine development and the clinical trials. So we know that the particular effect of pandemic was actually starting in at the initial point of December, and later it took a full swing in the month of January and February, with the European countries being the most volatile or the susceptible ones. So how are we effectively using AI to uh, you know come up with vaccines for this and for the clinical trials? So there are companies who are actually depending in and banking in on AI technology for coming up with the molecular structure of vaccines. So the best example is VIR biotech, bioinformatics, I think. So that is the company which is kind of banking in on the exact virus structure, and what kind of a particular protein would actually disarm the particular virus. So here you can see in the diagram which I have attached. So this is the complete structure of the COVID-19 virus. So the inside part is the uh, one which is containing the RNA, or the exact coding part of the virus, which actually reciprocates and replicates itself and starts to infect other individuals. So the image of the COVID-19 structure was actually taken in with the help of the electron microscopes. So there were swab tests which were done on the individuals who were actually having this particular virus, and when they were analyzed under a exact RNA deficient microscope, so they were able to come up with this complete structure. So what this basically helped us to do is, this helps us to kind of prepare ourselves, and this kind of gives us a picture of the enemy which we are against, and then the next strategic points can be actually deployed. So as you can see, there are spike proteins or the glycoproteins which actually attach themselves, and they start to replicate the whole RNA part. So what that basically means is, this exact virus structure is going to go into the respiratory system, and on the respiratory tissues which are there on the lungs. So they are going to attach themselves with these tiny hooks, or which we call as the spikes. And once they are in, then the RNA or the whole core of this particular virus is gonna re-replicate and duplicate the data which is there inside that particular virus, and thereby creating a large number of copies and spreading it. So coming back to the AI part, so with the detection of this virus structure, it's not an easy task, even if you have the complete swab test or the petri dish full of samples, because on an electron microscope level, so you need to be very specific on the exact thing which you're looking in for. So since human beings are bound to errors, and it is not a day-to-day mundane task for a scientist to just sit in front of the electron microscope images and just try to figure out what is there and what is not. So what we have implemented with the advancement of the electron microscope is, it is linked with an image processing system which actually detects and looks for any anomalies in the existing patterns. Say for example, if you have the sample of your blood placed under the microscope, so things should look in a similar way. Like you have your RBCs, WBCs, and platelets which are supposed to be present, and we know that these are the exact constituents which are needed to be there, and anything which is apart from the existing known structures is foreign body. So that is how it can be differentiated, and that is how with respect to the detection part, we have come up and used the existing AI front. So guys, and on the other front, this particular session will be on an intermediate level and the beginner level, and not to a complete expert level. I don't want to bug you up with complete code base, how the things are done and all the other stuff. So if you have any kind of doubts, I will be glad to take it up and answer to few of your queries over the emails. So that particular channel is always open. So just a disclaimer on that particular front. So coming back to the vaccine development phase. So since the virus is well defined, and how the antibody reactions are going to be there, so we are going ahead and we are trying to come up with the exact vaccines which can actually prevent the spread of this virus and help us to get back to our lives. So the logic is pretty much simple. I'm just translating it up to the normal human being levels. So the first part is like this exact protein spike which you see gets attached to the existing cells, and that is how the whole process gets started with the virus spread. So the whole idea with vaccination is to come up with antibodies which can plug the existing structures on the spikes, and the virus will not get attached by itself, and it will not spread. So that's as simple as we can make it in the layman's term. But to achieve this, it is not that easy, because you need to have a specific protein which can bind to your spikes, as well as with which does not cause any other involuntary actions in your immune system. So it is easier said than done. It's such kind of a scenario, but with help of AI we were able to kind of zero in on the existing structure, and this kind of expedited the process from where we are actually going ahead. So yeah, I think I have Bharti. Hi Bharti, do you have anything to ask in? I see you're unmuted. Okay, I'll just mute all. Yep. So the next part is with the infection spread. So this is one of the articles which was released in March, and it's by Professor Will Douglas, who is currently serving in at MIT, the Massachusetts Institute of Technology, from the health division. So he basically stated that on December 30th, an AI system called as Blue Dot uh, actually used ML algorithms, and it actually predicted that there is an outbreak which is there, and which is on the wider spread. So how was it able to do it, and what is the advantage of that? So basically, what Blue Dot does is it's the advanced AI system which is trained on multiple disease and the data sets of the disease from the historic path. So starting in from your common cold, flu, and your deadliest diseases like Ebola, AIDS, and the other ones. So all the existing data set have been fed to the Blue Dot uh, machine, and when the Blue Dot was able to actually get the exact data sets coming in from across the world, from different hospitals, so it was actually noticing in that there is an unusual number of raise in pneumonia cases, especially in a particular province of Wuhan of China. So that is how powerful these particular machines are, and that is how powerful AI is as of now. So so we have a saying in the community, or the data science community, that your model or your data set which you provide, uh, is directly proportional to as good the system can be. So indirectly speaking, the more quality data that you feed, the more advanced and the more effective your system will be. So what this basically tells us is, with a proper trained system, the detection of such kind of a pandemic can be at a much more earlier phase, and it can help us to take up corrective actions and prepare ourselves to tackle this particular situation. So with the existing data set, so Blue Dot was able to kind of raise the red flags at that particular point in time. So then it was left to the humans who are actually manning those systems to actually interpret those results, and how the actions which they are going to take against the same. So that's the way in which we can try to detect such kind of further outbreaks with the existing data sets. So on the similar ones, so Blue Dot was not not alone this single system which actually detected the spread, and we have other systems as well, uh, which was the automated system which was called as the Health Map, which is actually owned and maintained by Boston Children's Hospital, which also caught the signs of early outbreak, and which actually help us to kind of avoid the further spreads. So I think I see Veena. So ma'am, do you have any questions? Okay, okay. I think that was by mistake. Fine. So that is how exactly we are looking in at the stopping in of the spread phase, and that is how we can better the systems and go with the existing approaches. So going ahead, so we all know that in the existing phase when we were fighting up with COVID, so there were cyclones which were actually there, and across the world there were other issues which were also there, like the great Australian bushfire, the tornadoes, and the you know the ice storms or the sandstorms in the Middle East. So all these kind of disasters, or the natural disasters as we know, are kind of well documented, and we have enough data sets so that we can say confidently that this particular thing is gonna happen, and we can prepare ourselves. So the biggest one was with respect to the Odisha cyclone, which actually hit in, and nearly 2 lakh plus individuals who are actually living in that area or the coastal region were evacuated. So without a proper alerting system, without a proper guided monitoring, so that would have not been possible. And we are analyzing a larger data set which is available over the years, and we are constantly monitoring all the changes which is actually happening over the land as well as sea. So that is where the AI systems are being used. So basically, when you get a temperature differential between the temperature of the sea and the temperature of what land, so that is when the existing winds start to blow in the opposite directions, and that is why you have cyclones. So in the northern hemisphere it's going to be on the anti-clockwise, and in the southern it's going to be on the clockwise. So that is the entire story. So going ahead, there are systems which can detect the temperature difference between the land bodies and the adjacent water bodies are associated with that, and predict the next cyclonic depressions which are going to hit the land mass as well. So with those advancements, and with the weather forecast departments working hard, so we are able to actually sustain few of these natural calamities. And the same kind of strategies can be applied to the pandemics, like the COVID-19. So with the larger data sets which we can accumulate at the time of this pandemic, are going to help us and are going to make our AI systems much more better when they actually are deployed and when they are asked to perform at the same scale. So in the last point, that's the same thing. Data from the past actually fuels such predictions and help us to save lives. So it's kind of positive approach which we can apply is, even during the situations of this pandemic, we are mainly focusing on data collection. And that is the reason why we are actually doing it, to make our systems better, and how to analyze the existing situations and the mistakes which we did during our last pandemic. So coming up with the diagnosis and treatment front, so this is where things start to get onto the existing AI part. So with the diagnosis and treatment, we all know that there were COVID testing kits, which were PCR tests kits, which were imported from China, and China was actually the biggest supplier of the kits to the entire world. And the major problem with using those particular kits was that they used to give kind of false positives and false negatives at times as well. uh, so we all know how many times few of the influential people were tested, and say for example, out of 5 tests, at least 3 of them came negative. And similar is the kind of situation in which we were dealing up with. So there was a lot of media coverage which was actually given to a uh, Bollywood singer who actually recently visited London, and after that, coming back to India, she visited multiple places and she was tested multiple times. And each and every time the test was conducted, even though we have the probability of zero point 0.5, but it used to swing either ways, and later she was diagnosed as corona negative. So that is the ambiguity with which we were dealing at the initial point of uh, the pandemic. And with the help of CT scan, uh, so what the researchers were able to do is they were able to take the image, or the radiologists were able to do is they were able to take a CT scanned image of lungs of the individuals, because the COVID-19 belongs to the SARC family, and it infects the pulmonary system, as we call it, or the respiratory system in general. So most of the effects which we see are on the respiratory aspects. So they took a CT scan of the existing image, and they tried to analyze, with the help of the trained radiologist, that is there any kind of signs of viruses or the development of the pulmonary related issues. So remember, we are talking in on the early diagnostics front, where the disease is not widespread and it is not completely fatal. So it is there at its second phase, where it is developing pneumonia like symptoms, and we are kind of running out of kits, and this is the exact solution which the Chinese scientists came up with. So as you can see from the charts, so which I have attached, so you can see that you have the first image, which is a normal one, which is given in by your radiologist, and this is the CT image. And when you actually train this CNNs, what we call CNNs are nothing but convoluted neural networks. So I'm not going to get deep onto CNNs or anything of that sort. So just remember that this is CNNs are something like which are designed like your brain or your neural network, where one of your feed is passed on to the next network, and with the help of learning it is going to come up with a existing result. So what basically the scientists did is they fed the CT images and made these and made use of the CNN algorithm. So they were able to detect the tumor like structure or the pneumonia like symptoms accumulating on your lungs in a much more faster and an effective way, when compared to that of the different tests which we used to do, or the PCR test which we used to do. So what it actually helped us to do is it kind of created this particular scale of probability of COVID-19 being present on that individual. So from the images, it is kind of clear that uh, it is kind of easing out the job of the radiologist, because they need to take multiple shots of the same image, and they need to analyze the images on a manual front. So with the help of trained OpenCV AI systems and forwarding the existing feedback loop to the CNN networks, so instead of looking at 1,000 images per day, the radiologist need to look at 15 images at least, which the system thinks they have positive corona positive symptoms. So that is the extent in which AI is being used, and it is kind of helping in at the diagnosis uh, and the other fronts. So this is the exact link of the article. Since I'm a research scholar, so I tend to document few of the things which I read. So that is the reason I have added it up onto the slide as well. So kind of remember that this slides and the contents are not 100% the things which we'll be discussing with, because these are just the pointers which we can see, and it's going to help us to just remember the same things and the discussions which we had. Uh, so the next front with respect to treating all of them is actually deployed on the Pune railway station. So you might have seen this particular news of a robot, trying to screen individuals on the thermal scale and the other stuff. Going into the exact details, so the name of this particular robot is Captain Arjun. So the whole purpose of this system is to detect individuals at the railway stations, do a thermal screening of the individuals, and we know that one of the major symptoms of the COVID-19 patients is having a high fever and a pneumonia like situation. So that is why the governments have mandated the thermal screening at places, and use of hand sanitizers as a mandatory thing. So we know the steps which we are taking to kind of fight it off. So the same steps were actually implied at the ground level, and this particular robot was created, and it is currently working in Pune stations. So what this particular robot does is it detects humans with object detection, and it just encounters any individuals who are having any kind of difficulties with walking, or kind of cough or sneezing. So all the existing data set which actually contribute to any kind of dissimilarities or devious behavior is fed into the robot. And this particular robot approaches the individual, take their thermal screening, and if it is below a particular limit, so the threshold, and it will go ahead and prompt them to use the hand sanitizer and the other things. So this is how exactly it is being implied at the ground level. So if we had not known the exact symptoms at a much earlier phase, with this help of, with without the symptoms, so we cannot detect the existing individuals who are having the issues. So that is how the analysis from the last slides actually delegate or trickle down into. So there are other tasks which this particular robot can do, like disperse sanitizers to the individuals, and also the usage of face masks. So it also contains the audio feed which actually describes the features which are exhibited by the individuals when they're affected by COVID-19. So there are fronts in which we can go ahead and advance this particular robot, but this is the ground level front where we are using the AI systems to actually fight against the pandemic. So what is the use of having in a robot when you have individuals who can do it at a much faster rate and much more effectively, because that is how the human beings are. So they're trained to adapt to different situations, and they have their own thinking which enables them to take corrective actions. So the advantage of having this robot is, the first one is contactless screening and dispense of things. So no matter how much cautious the individuals are, so when the human factor is involved, there tends to be errors. Say for example, on the other day when I went out to get few of the essentials at Big Bazaar chain, not to defame anyone, but uh, the individual who was there at the security counter actually forgot to thermal screen me, and this the sanitizer dispenser which was actually attached to a footboard. So I tried to use it up, and it didn't seem to disperse the sanitizer. So what this individual did is he removed his gloves. He just took a dig at the machine, and he thought that the spring was having an issue, and he fixed it, and he touched the bottles and the other stuff while performing the action. So in spite of clear instructions, so that is the particular place where most of the individuals might have walked through and touched that particular machine. So he had to expose himself. So that is the kind of humane approach which we have. But in case of a individual robot, so you have a option that you are taking that humane factor out, and in case of battery replacement or anything of that sort, a trained individual will take care, and we have wireless charging technologies as well to charge the existing robot. So that is the thing which actually is coming onto the table with respect to contactless screening and dispensing of things. And the next one is with respect to avoiding human to human interaction. So the spread is actually severing with human to human interaction, and that is why we have the complete social distancing norms. And with the use of these robots and the humanoid robots, so the human to human interaction is kind of avoided. The most important aspect which I would say is to uh, kind of maintaining the individual details. So this is not actually implied on the existing system. Say for example, if the system actually detects an anomaly with the behavior of an individual, and you have the complete details of the individual, And as you can see in the camera, which and the image, it has an integrated camera on top of it. So just if we can take a snapshot of that particular individual, and if we maintain the existing database, so it becomes much more easier to actually maintain the travel history of the individuals, who are the other individuals who are present in that particular travel medium, like the train or an airplane. And that is how effectively we can tackle the existing pandemic. Even in case of individuals turning positive, then we will have a record of all the travelers who are there and who are accompanied. In case of air travel, this is much more simpler and easy to achieve, because all of the individuals will have their own passports for international travel, and for inter-state and inter-district travel, they will have their flight ticket numbers. So they will be knowing their origin and destination, and we will have enough amount of details to basically track the individuals. But in case of train travel, it's a nightmare. And such kind of AI systems like Captain Arjun can actually help us to basically track the individuals and also provide a positive feed to improvise on the systems. So that is with respect to tracking in. And this is one of the favorite quotes. AI is important tool which is versatile, and with right amount of creativity can help us immensely to achieve greater feat. So it's just um, the alphabets of a particular language, and how you create words, how you frame sentences, and how you narrate your own story depends on the individual. So coming on to the same example, like we were all given same set of education, we were given the same starting point, but how the exact individual make use of that knowledge which he has accumulated is going to end up in different walks of life. So that is the same scenario. So AI is like the existing alphabets of a language, and it basically depends on the data scientist or the data engineering front who actually implement these systems to give a better understanding and how the things are actually implemented. So it is like giving you the raw power, and it depends on you how you are going to use it. Okay, let's move on to the next one. The next front is with respect to treating of the patients on uh, different individuals who are actually being tested positive. So we have a scarcity of resources on the uh, ground level, which we need to acknowledge in the first place. And we need to basically take it up with the existing deficits which we have. But in few of the places of China as well as with European places, what they have come up with an alternative is they are coming up with similar robots which are humanoid in nature, and who can actually perform the duties of a nurse for serving food or taking medical readings and raising the flags when there is any kind of discrepancy in the working. So what this enables us to do is we are putting minimalistic lives at risk. And I think all of us remembers the photos from the healthcare workers and from the doctors when they wear the PPE kits, which are like very scarce uh, as of now. And the amount of dedication they need to have, because once the kits are on, you cannot take a break to urinate, you cannot have food. And that is the stretch of hours you need to work with the same kit. And with temperatures, with subcontinental temperatures like India, where sun shines are on the higher side. So due to profuse sweating, uh, it leads to rashes on the medical healthcare workers as well. So we are kind of trying to avoid the healthcare workers risk by actually implementing few of the humanoid robots. And that is one of the other ground level thing which is getting implemented. So I have attached the keywords for the blogs and as well as the YouTube videos for the systems which have already being used in advanced countries where you have enough amount of resources, and you don't have enough human power or manpower, as we say, and robots are helping out on to fight this particular pandemic. So the next one is with respect to the simulations and the drug tests. So the human trials of the drugs have been uh, at the last front, and unless the clinical trials passes 5 levels, so you cannot test the drugs on the humans. So that is the moral obligation, and that is how the world has been working in. And you cannot have dig or relaxations on top of the existing norms. So what AI based systems have done is they tend to simulate the existing uh, COVID positive patient symptoms, and the individuals actually are out, and they are not basically part of the tests. So it is the exact humane system on which the drug effects are tested, and there are n number of variable factors which are induced. Say, will the medicine actually work on small kids who are below 5 years? So the same can be simulated by actually replicating the immune system of the 5-year-old kid. So we are able to do it based on the existing data which we have, and that is kind of leading us in the same front. So okay, sorry for that. So the next one is to reduce the false positives and by data analysis. So we discussed on this on the PCR test kits for COVID-19, and how we are using CT scan to avoid the false positives. But also remember, the testing mechanisms which we are following are also giving you false positives. So we can attach the existing additional data set of where the individual is coming in from, and what was his travel history, and attach that with the existing test result to reduce the false positives. So we might have heard about news of few of the individuals who are testing positive even in spite of being in home for more than 20 days, and individuals who are tested positive but the remaining family members tested negative. So these are examples for your false positives, and with the exact additional data set, that is, if all the individuals in the house are tested negative, so if one of the individual is testing positive, then we can come to a conclusion that there might be an issue with the existing testing kit, or we might decide to kind of retest the same individual on the similar kind of front. So that is the exact analysis which is actually implied. So it seems much more simpler when we are discussing at individual levels, but just have a bigger view picture when India is conducting more than 1.5 lakh tests per day on a individual state level, and you have all the data which is coming in from different states, and how hard will it be to uh, trace the false positives, and how to differentiate between a false positive and a uh, positive case. So it's a from the bigger picture, and as the data volumes grow, so this becomes a major issue, and that is how we are actually tackling it up with help of AI. The the asymptomatic nature of COVID is also posing in as an issue as of now. And what this means is, like, if patient A is showing certain kind of characteristics, say high fever, dry cough, and trouble in breathing, so they are kind of considered as normal symptoms. But there are few individuals whose immune system is strong enough to kind of fight against the existing virus. So their traces or their swabs contains the presence of the virus protein, but the individuals are not showing any kind of symptoms. So that is what we call it as asymptomatic nature. So this is also another challenge to figure out who is actually positive and who is negative, and that is actually taken care and helped in by AI. So the first approach, how we can differentiate between the different patient traits is, what is the demographic location. Say, for example, in a colder country like UK or London, for that matter of fact, what are the symptoms which are actually showed by individuals which are dependent on that demographic nature. So people living in colder countries used to tend to have reduced immune boost, and they are more susceptible to small colds or cough and cold, which we basically call it. So that is why we have a little higher alcohol consumption to increase the body temperatures at the colder countries. But when coming on to subtropical climate, or as we move nearer to the equator, the APAC countries, where we have India, Pakistan, Bangladesh, Nepal, uh, Sri Lanka, Myanmar, Thailand, and so on. So the climatic condition is a little more similar, and we have individuals who are uh, adapted to a very high temperature and functioning in that particular temperature. So that is also stated as one of the major reasons why we don't have such high mortality rates in India and in APAC region when compared to that of European countries as well as the American countries. So in terms of asymptomatic nature, we can use the existing data set from a particular demographic nature, and we will be actually going forward and comparing the symptoms which are there specific to that geographical location. And that is how it is being used. So this is starting up with the fighting phase as well as with the usability and how it is actually getting trickled down onto um, at the ground level and functioning in. So all the government officials and the contracted government officials are advised to install Arogya Setu, which is actually developed and launched by National Informatics Center, because the it is under the Ministry of Health and Welfare. So it was launched on April 2nd this year, and it's having an record of being the fastest app to reach 50 million downloads in 13 days approximately. So the Indian government mandating the use of an app to track the individuals and also to pinpoint the locations of individual was criticized more in few of by few of the uh, individuals who actually bring up the privacy issues. But from an individual perspective, what I feel is like it could have been a distributed system instead of a centralized authority containing the data of uh, all the individuals present on in a particular country. So that gives a lot of data on the individuals who are present, and it's like a gold mine to be explored. So a single government authority can use it, and uh, that is the extent of the usage of Arogya Setu. So we all know what are the functions which it used to do and what are the things it used to detect. So you are familiar with the questionnaire which actually pops up when you install the Arogya Setu app, right? So it basically gets the details like what is your the name, what how old are you, and what are the things or symptoms which you might have. So that is based on self assessment, which we call. So after the self assessment, the system will decide based on the inputs which you have given whether you are most likely a patient or susceptible for virus, or if you are having the exact symptoms as mentioned by the WHO norms. So that is done on a self assessment ground. Let's not get into the complete details of the ideal tests or the ideal test questions, but that is how the exact app works. But the major thing which I liked about the app is the geo tagging or the geo information tagging which it does. So it actually requires your permission. I don't know how many of you have observed when you install the Arogya Setu app, it will ask for your storage permissions to write and read from your existing mobile device. Next is to monitor your phone calls, and the next one is with your GPS locations, um, and the next one is with the Bluetooth connectivity part. So the first one, important one which I liked is with the GPS tracking. So what this app enables the individuals to do is, without exact human intervention, it comes online every 15 minutes. The app actually initiates a thread in the background of the mobile app, and it will send the exact locations, that is the latitude and longitude of the existing GPS location of the individual, to a database server which it is connected. So what this enables to the government to do is, it gives a tracking information of individuals, where they had been, what is the exact time which they had kind of spent in that location, and are there any other individuals who are actually present and around the vicinity who are kind of susceptible. So this is to actually fight the existing spread. Say for example, if an individual who was working in as a police officer has installed the Arogya Setu app, and he's tested positive. So what this allows the government individuals to do is, they will backtrace to the travel history of that particular individual for say about 15 days, and they will track where exactly the individual have moved, and with whom others he has actually had an interaction with. So the immediate family will be quarantined. That is a no brainer. But how many other individuals will were the contacted uh, person actually helped in spreading, or was it effective enough to actually get contained? So that is how it is actually being used. So with the help of Arogya Setu app, they're tracking the GPS locations, as well as the individual's name and the age and other kind of information, which can help us to narrow in on the spread. So that's one of the important valid points. So there are companies like Google and Apple who are actually trying to come up with the GPS level tagging from a phone level rather than an application level. But it was actually tossed out from the European Union that it is against the privacy policies, and no matter even in a pandemic, that the privacy breach is allowed. So that is the reason why it is kind of taking in a backseat. But in a country like ours, we have went in and implemented the system and mandated it for the government individuals, as well as the other subcontracted individuals as well. So the analysis and the points which I'm going to mention about Arogya Setu are done on a very personal level, because there is no open source code for Arogya Setu app. So even if you search anywhere, and even if the informations are not requested for by the app development team, so they haven't disclosed the same thing. Like there are many nuances with this app, like where all the data is actually stored, who is actually owning the data, and how secure is the app, and how are the exact details are being used to fight against the existing COVID-19, and how effective is it for contact tracing. So all those details are not available. So whichever the things which I mentioned about geotagging, and the app coming online every 5 minutes and the response being sent, so they were tested out on my personal device, and on any Android device you can see that what is the amount of traffic which is going out from the device, and which are the applications which are actually using the resources, like your speakers, your network, your display at that particular point in time, and it was tracked using that. So there is no official government documentation on this app. And going forward, so the other advantage or the versatility of this app, which we can say, is it is available in 11 languages. And long gone are the days where we used to have language translators who used to come up and uh, do the transcripts and the other stuff. So now we have Google translators. Most of them, they use the Google translators nowadays, and with the help of simple English language, the same can be translated to vernacular languages like Tamil, Telugu, Kannada, English, uh, you know, uh, whichever the languages which you actually name. And that is how the existing app writers are also using the same app to be more versatile. There are many challenges which we see in the same approach, but it is the one which is actually followed. So why I actually brought up this point is, with the short period of time, I think the lockdown was announced from March 15th, and by end of March we were having in an app which was ready for contact tracing and able to give us a better approach to fight against COVID-19. So that actually explains us how quick the app development time was, and how effectively we are using the existing technologies to kind of fight the existing uh, pandemic. So the simplistic thing which they have done is they have replicated the same language options. So if you try to use it in Hindi or Marathi or Kannada, so the same backgrounds, so the same settings, and entire thing remains the same apart from the language which it is being displayed. So that is with the help of different language settings which you have on your individual mobile phones. So always remember, it is not delegated back from the existing systems. Whatever interactions you are having, that is having in at a cell phone level, and it is not the same data which is being stored at a database or at a server level. So yeah, so coming on to the AI front, how exactly the contact tracing is done. So since we don't have the exact details of the app and its working, so what I bet on a personal ground is either they are going up with k-mean clustering, or the next approach is the n nearest neighbor, or the knns which we call it. So how exactly this algorithm works is, we actually tend to identify individuals, say for example this X mark, and he was tested positive for a particular coronavirus case. I think it's Deepa. What? Hi Deepa, do you have any questions? Okay, I think it's by mistake, so I'm just muting off. Okay, so coming back, so since exact documentations are not provided, so how K-mean basically work is, you have an individual who actually is tested with corona positive. So we actually take out the geographic locations or in which that individual has been, and whoever is using the Arogya Setu app are listing a geographical location closer to the individual who has tested positive. So that is your first cycle of the individuals who are tested positive, and the next one is after the individual contact with the other human. Deepa, do you have anything to actually mention? Okay, okay. I think it's going out of mute. Uh, okay. So basically, how the contact tracing works is, that particular individual will be marked as the center of the cluster, and he will be having multiple contact points. And with each iteration of the cluster going through, so we will just mark the individuals who are coming in contact, and we will be getting back to those individuals and testing them up, and the process goes on. So this is how K-mean basically works. So these algorithms which we see are part of machine learning front, and they are used on a very general level, and uh, that is the beauty of it. So everyone knows about k-mean and everyone knows about kNN, or the nearest neighbor. So but we haven't thought of applying it on a geographical data set, and for a contact tracing. So that is the beauty of implementation with simplicity, and delegating it to the ground level things. So the next front is how exact things are being translated at the ground level. So we saw in terms of testings, in terms of functionality, in terms of uh, other aspects, how AI is part of this whole fight against COVID. But how effective is it at a ground level? Are we seeing any kind of results? Or what is the use of this particular technologies? So that is the bigger question which we have. uh, so coming up with answers on that. So most of the data which we are collecting right now during this particular pandemic, so if you just switch on a television, so you will see the statistics, like, this many people tested positive, this many have deceased, these recovered, and all these kind of statistical data. So when you see such kind of data, so in India alone, we have crossed around 4 lakh individuals who are tested positive. And just imagine the amount of data attached to all the individuals and the patient treatment records, and how much amount of time we need to spend on kind of analyzing all those reports. So that is when we make use of existing tools like big data and parts of AI, that is NLP and other technologies, to effectively analyze the existing data set which we have collected. So most of the data which we get is either textual or the statistical part. So the textual data which we are collecting is kind of on uh, the medical reports which we have and the medical history of the individual, the treatments implied, and other important textual contexts, like if the individual who is tested positive for corona was having any kind of prior symptoms to this particular disease, like a health condition.
Huh.
Hi. Hi, Sunita. I see that you are on unmute, and okay, that was by mistake. Okay. So with the amount of medical history and the treatments implied, we will be in a better position to treat the individuals for that particular symptom. And that is how the exact implementation will be helpful with. So just imagine the amount of documentation which will be getting generated once you join a hospital. So they will need your complete profile, like are you allergic to any kind of medication, are you allergic to any kind of
Hello. Hello.
Hello? Yeah, ma'am. We can hear you.
Okay, sir. So nothing. I just wanted to check, sir. In between, your audio was not audible. That's why.
Oh, okay, okay. Sorry. I think that might be because of a internet lag.
So just,
Um,
I think 2 or 3 minutes, there was some lag. We were not able to hear you.
oh, okay, okay, okay. That's
Okay,
fine.
sir.
That's fine.
Yeah. Thank you, sir.
Um, yep. Since we have taken in a small break, I'm just checking in for chat if we have any kind of questions.
Yes, sir. I
Um,
had posted the questions, sir, to you.
yep, I can see individuals in their yep audibles. So that's what I'm getting in. So yeah, is diagnosis of infection using AI methods applied practically? So yeah, that's the one question which was actually posted in. So I'm going in at the descending order. So the answer to that is yes. Um, so I have given in the company names who are actually using AI to analyze the existing infections which are actually being diagnosed. So when the patient actually comes up with an ailment to the hospital, so the first thing which they do is the doctor does the preliminary checks, like check the heartbeats and bunch of other stuff. So what that actually helps us to do or analyze is Is he suffering from any kind of basic diseases? If it is not, then we prescribe a bunch of tests which actually match the symptoms of the patient. So instead of doing all the existing manual efforts, so we have the test results and we have the symptoms being matched, uh, being analyzed at an AI system level. So if you want the exact names of the AI systems, I'll be able to provide that. And apart from that, I think I have posted in few of the helpful links at the end of this PPT, so you guys can go through. So the next question which I see is it possible to possible for multi-class classification for disease question from, okay, multi-class classification for diseases? Yes. So this is why the AI is such a beautiful tool, because as you have seen with the recent things which are actually coming up in newspapers. So the percentage of individuals who are having in an age group of uh, you know lesser than 10 years and greater than 50 years are more susceptible to COVID-19. So this amount of analysis was only helpful uh, when we were analyzing larger set of multi-case data. So whatever the data which we are getting in from individuals who are tested positive, or from the individuals whose data is with the system, right? So what we basically were able to do is we were able to attach the symptoms which are showed by those patients, and we were able to use the classifiers to basically set the classification of the individuals. Say for example, if they are coming in from a particular demographic condition, like APAC countries, what are the different set of symptoms which they are showing up? So we have COVID-19 positive, that is the same common set. So for the multi-class classifications, so what kind of age group will he belong to? What kind of ethnicity which he belongs to? What is his travel history? What is his family's resistance? Was his family having any kind of susceptibility to uh, cancer, or were there any ailments which were already there? All these kinds of analysis will be done from the individual data set level. So we have multi-level classifications for the existing individual level data, and that is how you can see all these analysis of how the exact drug is going to work. So we have the Rantivir drugs, which was actually prescribed, right, which was in vitro, and it was not that effective in terms of Ebola. But a few of the researchers now they're actually trying out multiple drugs which are based on similar kind of a virus structure, and they are trying to analyze whether the same drug will actually work. So that is the exact amount of information which they are gathering, and that is the exact intent with which they are looking at data from multiple angles and from multiple dimensions. So there was another important study which was done in that, which stated that COVID-19 is most probably to be uh, infected to individuals who are affluent. That means it actually is affecting rich people more when compared to poor people. Why? Because they were tying up this existing data set to the travel history. As we know, in a country like India, where we have democracy and the literacy rate is kind of uh, low when compared to the rest of the world, and on the GDP level, that is the gross domestic product, so we are at the lower level. So that is why we are defined at a developing country. So in a country like India, you will be shocked to know that uh, not even 8% of the whole population of India has done some kind of air travel. That is not even like around 50 lakh or 60 lakh individuals, not exceeding that, have done a air travel in their entire lifetime. So that kind of puts us at a very low risk when compared to being exposed to countries which are far more susceptible to COVID-19. So in a same example, if you consider countries like London, or anywhere with Germany or any of the other things, so you will find that this particular data set is on the contradicting side, because at least 40 to 45% of the individuals are involved in some kind of an uh, air travel. Either it can be an interstate or an inter-country, but that is how the numbers are depicting. So that is one of the best example which you can get for the analysis or implementation of the analysis part. So I have another question where we can get the data sets by Sapna Gupta. So Sapna, we have a COVID-19 dataset available at Kaggle, and there are other institutes like the JHK or the John Hopkins Institute, uh, who are individually contributing to the trackers. So you will be aware of the world level trackers, right? Like how many COVID cases are positive, how is the spread of this particular disease being analyzed, and all the other stuff. So that is where all the data is getting stored. And if you want much more details on how the things are getting stored, since John Hopkins is one of the clients to our company, and they are having big data clusters to analyze the existing data flow which is coming in into their systems. So whatever the existing data which is being generated on the world is kind of ingested onto the big data system, and from there it is being analyzed, and the graphs and the different systems which you see are kind of being populated. Um, so the next question which I see is whether detection of swine flu and COVID is possible by using common variables. Uh, so by using common variables, as if using the symptomatic data set, so individuals who tend to have similar kind of symptoms, that is what the system is actually doing. So when you basically go to a doctor with any kind of issues or ailment, so first thing which he checks is like, from which particular location are you coming in from, what is the common kind of diseases which are available. So you are aware when you take a kid to a hospital or to a doctor, right? So the first things which he does is he will just place his stethoscope on and check the heartbeat, and the next one is with the pulse and a similar kind of a thing. So he's basically checking up for symptoms which can actually relate to the disease. So we are actually going the other way around. This is reverse engineering. So coming back to the same question, whether detection of swine flu and COVID is possible by using common variables. So I think yes, but the classifier which we base it on is something which is debatable upon. Say for example, you have similar kind of features for swine flu and COVID. So after segregating a larger set of data based on the existing information which you have, so you will end up with a single digit or a two digit patient records. So how basically you are going to classify by digging more onto the existing medical records actually define a few of the things. So when we actually check for COVID and swine flu related stuff, so you will see that swine flu is having a particular symptomatic characteristics like cold and shivering and high fevers. So the similar ones are also available in with respect to COVID, but COVID-19 is much more related and relevant to your pulmonary disease or a respiratory disorder. So we can take those particular attributes and the tests which are there. So that is LFT, that is the lung failure capacity test, I guess. I'm not sure of the exact medical terms. So uh, the lung tests which we can do for the volume of air which the individual can take in, and we can bifurcate between swine flu and COVID with one particular common variables. So that is my answer. Sorry if I'm a little off the records and going ahead and answering these few of the questions. What I personally feel is coming in from the research background, that long gone are the days when we used to say that this is my domain and I am an expert in this and that is how it is. So the whole world is kind of moving on towards the interdisciplinary nowadays. And even if you are a good data scientist and if you know everything about machine learning and AI, if you are not able to implement that at a very ground level to solve the real world problems, it's not going to be enough and it's not going to suffice. So we need to be aware of the different interdisciplinary approaches and interdisciplinary actions which are actually requested. So yeah, with that I will try to continue with the things which we left off with. So guys, feel free to unmute and ask any kind of questions if it is going off, or if it is pondering in. So it's completely fine. I'm open, and I'll be taking up the questions over the audio, as well as with the chat as well. So going back, so we have enough amount of textual and statistical data which is actually available, and we need a proper system which can help us to analyze this particular data. So coming up with NLP, or the natural language processing, so I'll be just getting into a few of the medical related terms, like when you actually describe a particular symptoms of a virus, so you tend to publish it in a individual paper, or a scientific journal, or a medical community journal. So you are once again dealing up with textual amount of data. So what is the exact articles which deal with COVID-19 are actually analyzed by your NLP, and you will get a full protein mapping which can be used. That is, what are the different set of proteins which are present within that particular virus, the vaccine effectiveness and report analysis. There will be research which will be happening across the world for a existing pandemic like this. So we are not alone, and we are not the only country who is actually fighting this COVID situation, and there are multiple other individuals who are basically fighting the same battle. So uh, the different vaccines and the different advancements which is happening at different fields, so we can collaborate, and we can check with the existing studies and the reports which are already published, and how effectively it is being implemented. So the next part is with the target selection and specified actions. So say for example, we were able to find out from the existing data set that these are the set of symptoms which are actually showed by the COVID patients, and these are the exact molecular structures from the antibodies which can fix this particular issue. So how effective is it against multiple individuals across the board? So it can be working up with, say for example, with people who are having blood typing as O, and it is not functioning across individuals who are having blood type as A. So that does not define the characteristics of a vaccine, because vaccine is something which is not having enough amount of side effects, which is effective against the disease no matter the given external conditions, and which is actually available for uh, you know which can be mass produced, and which can be reproduced. The results of the vaccine should be on a reproducible level. So that is the characteristics of a vaccine. So natural language processing will enable us to go through multiple research papers, and pull out the details which are exactly talking about a protein which we want, or a vaccine which we want, or the exact symptoms of COVID which we are speaking about. So that is the advantage and the beauty of using NLP. The next one is which exact algo which we use with going ahead with NLP. So the best bet with that approach is BERT. BERT is it's like a bidirectional encoder which we use it. So say for example, you are having in a text data which is having this word like algorithm. So if you read it algo and rhythm in the from left to right, which is the common way, it gives a single set of meaning. And when we are using BERT, it simply does not read from left to right, but it also reads from right to left as well. Why? The word algorithm will mean the same. Say for example, the same common old thing which we were taught in the English grammar class. um, there are six sick people. So it can be read in multiple ways, right? So there are six sick people. That means either they are belonging to a particular sick community, or they are particular people who are individuals who are really ill. So this particular context, or being put out of context, will kind of have adverse effects on the existing studies which we will be making in. So that is why I personally have BERT, and we have Elmo and other uh, algorithms, but BERT is the best bet, and it is kind of backed in by Google datasets, and that is how the exact advantage is there. So we have something called as bag of words as well coming on to NLP, but as I mentioned earlier, so it tends to go out of context, and you need to basically deal with how it is actually mapping your existing data. So with the help of context, and it is with the context we are mapping the vectors to a multidimensional space with more weight on the context rather than the individual word itself. So this is once again the clustering example where if you can see here, so in the diagram at the left, so the words which are having similar kind of context and being used at multiple different papers are kind of segregated and grouped. So we can assume that all these papers who are actually describing these particular techniques are talking about the COVID-19 situation, and they are proposing a protein-based solution for this. So this is how exactly we are working on this one. So I think there was a question on the data classifications part, right? So coming back, what are the characteristics of the people who got the disease earlier, and what are the locations from which they are coming up with, and how are we mapping the hotspots based on the number of individuals who are tested positive for those particular locations, and then the susceptible locations from where they are coming up. So if we take the example of Bangalore, so we have closed up few of the areas and containment zones, marked as containment zones. So what that signifies is that that particular part of the city is having more number of individuals who are tested positive, and that is where the hot spotting is seen. That means that is the center of location from where most of the patients have originated, or they came in contact with the infected person. So that is how we are dealing up with multi-dimensional data. So the first dimension here is the location, then the second dimension here is the travel part, where the location is associated with that of the travel part, and the next part is what is the age factor of that particular individual. So that's your third domain. And what is the recoverability rate? So there are systems, there was a Kaggle competition which was actually aimed at predicting the rate of COVID patients and the recovery rate of those COVID patients. So we consider these multidimensional data into analysis front, and that is how we were able to do it. So the last part on this fight against this part is, like, we have heard of this term called as flatten the curve. So what this basically emphasized on was to slow down the effect of or the spread of coronavirus, so that we have enough individuals on the ground, we have enough amount of training for the people who are dealing up with COVID treatment, and also to provide enough amount of hospitals and medical facilities for individuals who are kind of working in on that segment. So that is the main advantage. And whatever the action plans which we have, like social distancing, cleaning, no large gathering, and reduce air travel, all of them were actually derived from past historical data. So believe me, you will be astounded to hear the sources of these things. So we, as human beings and as a human civilization, we have gone through multiple pandemics as well as multiple adverse conditions, right? So there was an early situation where we used to have plague, or we used to call it as black death. So just take that as an example and just see. So you might have individuals who were alive during that time, like your grandmother or your grandparents, who used to tell stories like, they never used to come out of their homes, and rats used to die off, and that is how we used to get in. So the part of staying in at home, that is the major contributor for social distancing. So this is not something which we have created or rediscovered. So it is kind of a rediscovery process which we are going through. So we are going through the historical data on how these conditions were treated and how effective we were with the approaches which we followed. And the second one is with respect to cleaning and the personal health hygiene. So this once again relates back to the swine flu days and the World War II times. So in terms of the number of casualties which we used to have during World War time, blood transfusion was not a option, and it was not known. And many individuals used to die out of profuse blood loss. So what was the advantage of that particular situation is, um, before treating any kind of wounds, we were supposed to clean those wounds, and we used to disinfect them. And the next part is, when the blood typing was done, we were supposed to give the exact similar type of blood group to which the individual belonged to. So this concept of cleaning and wiping off is actually taken in from that particular aspect. And there were studies which actually suggest that just washing your hands will is not that effective when compared with a combination of washing your hands with a a hand wash or with a soap based alternative, because the ends of the soap or the molecular structure of soap tends to get attached to the COVID structure, and that is how it is kind of cleaned off from any kind of surfaces. So that's how the cleaning and other decisions are backed off by data, and that is how we are actually using and reusing the same techniques. No to large gatherings is once again this implications of social distancing, uh, but at a very large level. So that's once again a no-brainer. And reduce travel, etc. So reduce travel, I think we can relate back to the same um, plague time, when it actually, the great plague, or which we call the Black Death, in European countries, which wiped out half of the population of Europe, was actually initiated or got instigated by set of sailors who actually reached to the shores of uh, Paris. So that is how exactly the things are going through. And we actually learned with reduction of travel from that particular approach. So even now with the current Wuhan situation, so with the banning of air travel, and uh, the individuals being restricted from entering a particular country, and also being imposed with restrictions, are doing much better job when countries who did not. The best example for this is US, who actually did not restrict air travel at a very early level when compared to India, who actually stopped the international air travel. And that is the reason why we have lesser mortality rate when compared to that of countries like USA, even uh, with a larger population like which we have. So that is how we are basically learning from our historical data, and that is how the current steps which we are taking are influenced by our existing data. So the source of textual data which we are using for analysis can be scholarly papers or research articles, and in few of the cases it is Facebook, Twitter, and Google search results as well. So this is basically done during a political campaign, or any kind of sentiment analysis which is done over Twitter. Uh, so this is quite common trend which people are actually doing. Earlier, before 10 to 20 years, newspapers and TV were the mass communication media. But due to the advent of internet, or due to the internet boom, so we are moving up towards social media rather than the age old traditional media. So the analysis of the same is also required. So there are organizations like the Cambridge Analytica. I think most of you know why they were famous for, and why it was kind of scraped out, and what were the actions which they took on the same front. So they were basically taking the sentiment analysis and the reactions from individuals on a Facebook based posts, and Facebook was held responsible for sharing user information with a private organization which is helping for an election campaign. So that is how powerful social media is nowadays, and that is how we are actually progressing on that front. So going ahead with the same, so we have an Indian native site. Let me go ahead and come out from the PPT mode. One sec. Yep. So this is the site which I was about to show in. So I think you guys can see my screen, right? So this is the complete source code of the Indian tracking system which we have. And if you are interested enough, and if you can, if you're good at processing few of the JSON data, you can go ahead and become a contributor. So what this basic site is doing is, it is gathering information from across devices, social media, WHO data, and all the other stuff, and it is coming up with a map like structure which we see, and giving us the total cases, active cases, recovered, death, similar kind of an info which the WHO site which actually gives, but at a very local level. So this is much more advantageous, and this is much more useful because this data is dealt at an individual level. That means if you're coming in from any place like say Karnataka, so you basically go in onto that particular state and you just click in and you will get a separate data set. So if you go into details, so you have individual district level data which is available, which is pulled across from multiple sources. So what is the test results which is being done? So if you click on the open source Git community, so you will get the complete source code of this uh, site which you are seeing. And if you want to be a contributor, where you need to send an email, and if you have enough coding skills, so you can go ahead and be part of it. So what they are basically doing in is they are taking in a subset of data which is fed to government, and they are displaying it on an interactive dashboard on a proprietary database which is developed by them. So I'll not get into the complete details of how the things are working, and it should be self-explanatory at that point. So this is the complete WHO world map, which is actually showing the total number of cases, how much deaths, and all the bunch of graphs. So this is the power of analytics, which is leading us to a much better and a much secure fashion, and to a better world where we can fight off any kind of diseases which we can see in. So if we just go ahead to one specific country, so you will see that what are the total number of cases which is there, and the similar kind of an info. So basically when I click on India, so you will see the last update time, that is CEST time, because it's maintained by the UN, and it falls under WHO. So these are the information which we can actually get. So coming back to the presentation, so few of the individuals who asked questions in the chat section, like where can we get the data set and the other stuff. So this can be one of the points, and the WHO page is actually pulling the details from the existing Google site. So if you can click on this, so you will be taken in to the existing site where the amount of data which is being pulled by your WHO is showed. And whatever the Google statistics that you see, right, when you try to Google COVID-19, so all of them are kind of backed in by WHO wiki page. So coming up with what next, we already know of a world which is kind of suffering from COVID, and what are the next steps which we can take in with respect to medical insurances. So as of now, the claims and the other stuff are still handled by individuals. Say if you fall sick, there is cashless facilities which is available by a few of the insurance agencies, but not all of them are able to adapt to what is called as the new age of internet. So they are not ready to either spend on the infrastructure, or they are not ready to either move to the new platform. So if you take an example of LIC, earlier the premium was supposed to be paid through an agent, and nowadays from past I think 4 or 5 years, so you can pay the premium and the other stuff over the internet. So that is how advanced we need to be, and that is where we are completely heading. So what are the next steps after treatment and precautions? So it is not a single time full stop that you are treated from COVID and you are good and you will be working functionally as a normal human being. So the effects of the drug which you're taking will also be there in your systems, and you need to be more cautious. And we are using AI to have the intermediate, inter-drug compatibility. Say, for example, the individual is having jaundice, and due to the immune system weakening by COVID, so what are the chances of that individual getting that disease again? Will his immune system be functional and able to fight off the existing things? So that is the amount of research which is being done. And the next one is the food and supply chain management. So during the complete lockdown period, so we all know how scarce the resources were, how the supply chain was completely distorted. Apart from milk and the necessary groceries, nothing much could have been gotten. So how can we better those systems? Say for example, you are there on a COVID hotspot like Maharashtra, and your state basically produces most of the onions which we have on the Indian market, and and if all the states decide to ban the travel and the food coming in from Maharashtra to avoid increase in their COVID numbers, how are we able to sustain with the existing food and the supply chain? So that is the extent in which the studies are going on with individual level of uh, things which we can actually implement. So what are the other sources from where we can get the same required materials or the raw materials? Since the exports have been hindered, how can we make use of all the existing resources which are being produced at a local level, and how are we able and good to utilize and consume all of that, and also kind of feed the globe? The next part is with respect to the preparedness for the next global crisis. So there are already task force teams which are deployed by WHO, who are constantly analyzing the steps or the success steps which different countries have, kind of taken in to fight off against COVID-19. So which are the countries who were effective and who had very less mortality rate? Say for example, in case of Italy, where they were severely hit and their mortality rate have crossed nearly 1.5 to 2 lakhs, and when compared with countries like India, where the mortality rate is minimal and the recovery rate is very high, and how are the countries who are more prone to this, and how are they actually winning the war against COVID? So all these task force job is to come up with best practices and the approaches which countries followed to fight off against this COVID situation. So this once again requires larger amount of data set, because it's the data set coming in from all the countries across the world which needs to be analyzed. So the last aspect is with the economic revival and stopping the spread of similar viruses. So I think they're kind of self-explanatory, and we can move forward on this one. So the existing systems and the automation of the uh, existing systems is the much more required operation which all the countries and the individuals needs to go through. So taking in the best example, my dad is a professor, and he was the hardcore educationist guy who used to teach in a board and a chalk kind of a situation, where he had specific skills to monitor the students when they are not attentive, if they are mischievous, how to deal with it, and what kind of things are supposed to be drawn on a blackboard to draw attention of the students. But now, due to the online platform and the classroom settings, um, he needs to evolve and he needs to adapt to the same, or else it will be very hard for the individuals to sustain in such kind of an environment. So coming on to the online classes and the other stuff which he's kind of doing in, so he requires some amount of time to get adjusted to the same scenario, and kind of promotion alert. So there is a session on the fourth day which actually deals with the effectiveness of teaching over the virtual classroom, because not all of us are adapted and well aware of the tools which we are using. So it will be dealing on that front. So this particular slide basically deals with the use and approaches of automation and how well we can adapt um, to the existing system, and how effectively we need to adjust ourselves to the changes in the existing system. So with respect to the individuals tracking of after their recovery as well. So we are on the onset of a second wave of pandemic, where uh, even after the recovery rate, few of the individuals are still started to show the signs again, and once again it is going to kind of have a spread on the community as well. So how intensively we are trying to accumulate the data from the individuals who have recovered, as well as the ones who are currently being treated, and how we can contain those spread to a very minimalistic geographical area is another challenge um, where we are yet to work on. So we have the existing data sets available, but how effective are we in terms of implementation, and how are the different tools like different algorithms from ML, or the implementation of AI, which we are lacking to bring it and delegate it at a ground level. So that is what the whole point of this slide was. So I think we dealt with the supply chain from Maharashtra example, and how susceptible and sustainable which we can become. Um, let's take in another example, because we tend to relate to the examples at a much more ground level rather than some US organization performing these steps. So in terms of my native, when the complete lockdown was there, so there was every individual was given a particular time period in which we were supposed to get the groceries, or the required things, and we were supposed to feed off on that, and that is how the exact mandate was passed. So after a lot of discussing and brainstorming with friends, so we got this idea of using the existing
ಇದು sound ತಪ್ಪಿಲ್ಲ
milk
madam.
delivery system.
Start video ಅಂತ.
ಇಲ್ಲ ನಮ್ದು ಸ್ಟಾರ್ಟ್ ಆಗೈತೆ.
Hello. Hi, ma'am. Did you have any kind of questions, or was it by accident? Okay, okay, okay. So coming back to the same example. So within our native, so we were actually thinking of using the existing milk delivery system to kind of piggy bank the uh, vegetables which are grown at remote places or from a rural background, since the milk vans used to visit all those places, and instead of just picking up milk, if they can accumulate all those vegetables which are grown, and since farmers were also restricted to come to markets to sell their produce, so this kind of eliminated the middleman, and we can have a common place where there is a proper interaction between a seller and the buyer. So there are individuals who are actually thinking on similar grounds, and there is a group which is already formed on that, and with proper backing and a few individuals and their contributions, this can be your new startup, where you just order your food, and exactly from which farm your food is coming in, and who is the farmer who is grown, kind of a Ola kind of a concept. So this kind of agrotech is also on the verge. So the COVID situation which we are dealing up with is not completely bad, or completely susceptible. What I would say is, I would say that uh, chaos is a ladder, and we need to see the positivity in all the aspects which we basically see, and we need to stand up together and fight against this particular situation. So this is the online class effectiveness and the other individual stuff. So basically, if we know the existing working of a particular tool or a particular system, it is much more easier for us to basically navigate and function using that particular tool. Say for example, this Zoom platform, since I was aware of this platform and I know the functionality of this, so I was able to better interact with all of you guys, that is around 100 odd people, to basically work and collaborate to come up with this complete online session. So if the learning curve is very high, say for example, if you have gone with a WebEx tool or something else which is available like Teams or GoToMeeting, and the individuals who are there at the presenting side are not aware, then the learning curve of that particular tool will be very high, and let alone the sessions and the other stuff, we will be ending up with technical issues, and we'll be not meeting the complete fronts. So reviving in of the economy. So I had one of the best examples, and this is probably the ending of the presentation part. So just bear with me, and we'll go to the question and answer section. So we are all aware of the different scams which happened, right? The scam. So during this pandemic and after this, the economy is already majorly hit, and we cannot afford to have a backseat at the similar front, and we cannot repeat to do the same mistakes. So when we were basically working at Refinitiv, which is part of subsidiary of Thomson Reuters, so they do a risk analysis of different individuals. So they had something called as Napier, as well as a word check. So what basically those software used to do is, when you go to a bank to open your account, so first thing they're going to do is they will check whether you are salaried, are you a business person, how is your income coming, and do you have any kind of bad loans, are you a defaulter. So all these checks, there is a software called as world check, where more than 5,000 banks are using that particular software. And when we were discussing about the similar kind of a problem which the PMC or Nirav Modi scam, so we were able to come up with a single cluster based approach, like which uses k-mean clustering. Say for example, if you are a faculty member and your income is basically say 50K, and if there is an anomaly with your bank accounts where your transactions are crossing more than 15 to 20 lakhs per year, so there is no way in which you will be able to cross those kind of transactions with just your income source or a single income source. So those we can use clustering approach again. And whatever the red dots which you see are identified as risky clusters. So what that means is, this particular grouping which you are seeing, right, so this can be done either on based on professions, or say for example based on the groups of individuals coming in from a similar background, or who are earning at a similar pay scale. And if one or two of the individuals are having a high uh, anomaly, that is completely fine. And unless and until the other income source is shown, the individuals can be checked in upon. So similar kind of an approach is already being implemented. So remember the demonetization part, right? So when that was done, all the amount or the cash, hard cash which was there, went into the banking system. And now we have the huge volumes of data which we have. It's that approach that we need to follow to analyze the existing data sets, and figure out the individuals or the linking of that particular individuals, how effective we can analyze the risk from that individual. So that is the way, and that is the length and breadth in which AI can be used. So these are a few of the very simplest techniques which I'm discussing over here, with clustering, classification, regression, and bunch of stuff like that, which all of us know, and which we all of us are comfortable in teaching. And we know basically how they work. And just the implementation part of the existing technology to the real world problem will end up and will help us to go a long way. So this is with respect to how we can spread uh, you know the awareness and stop the spreading of similar kind of an outbreak, with respect to using the existing systems, using the same design principles which we have already implemented, and going through the complete things which are already dealt with. So the eye-opening fact is that we need to keep ourselves updated and be advanced to tackle such kind of similar situations. So the other downfall or the pitfall which I see with AI implementation is, most of the decisions that we have and that we take are completely driven by data. So we all remember the initial part where the Chinese government actually did not disclose the numbers, or whatever the cause of the death and the other information. So basically, if you don't have enough amount of data set, the training time for your model as well as for your implementation becomes much more hard. And if you have falsified data or manipulated data, then a lot more time is actually wasted on your training phase of the model, which is kind of causing in the time constraint. So that's one of the biggest challenge. And with the whole world collaborating at the scale with which we are seeing, I think the data issue can be ignored to a level. But if you are having the initial data itself is being wrong, then it will take certain amount of time for the systems to recalibrate and come to the existing sense and come to the ground level part. So that's one of the things which I wanted to bring in. And always remember that specialization and other stuff are long gone days. So if you are having in the insight of how to use the technology, and if you are willing to collaborate on the educational front, on the agricultural front, on on the economical front, and how well we adapt to the existing technologies, so we can go a long way, and we can completely fight and win this fight against COVID-19. So these are few of the samples which you can try to search in Google and in YouTube basically. So I didn't get into complete GIS or how we are basically tracking in on GANs, because that would have been completely on the medical front, and I didn't want to make this session to an complete intermediate to an expert level. So that's the reason you don't see me showing off any code or trying to train a model, or try to run the model on any data set. So this was on a beginner to intermediate level discussion, and whatever the things which I have discussed are based on the articles which we have seen, and these are few of the keywords which we can use. I wanted to put in the bibliography, but it would have been a much more larger uh, thing, and it would have asked the individuals to put in more time to go through the existing stuff. So these are the few keywords which can help the individuals to uh, go through and uh, quench their knowledge on the same front. So guys, I'm open to questions. I think I have 2 minutes left. I will be just going through the chat for any kind of information or kind of feedback. Um, so whether the detection of swine flu, yeah, I was done with that. Useful prediction algorithms to control the outbreaks. So prediction algorithms is as effective as your data set which you are feeding. So either you can go with the existing data set which is having enough amount of data points. So if you are using the WHO data set, so you can try to replicate the different algorithms which are used by Blue Dot. So that is open sourced project which is actually being present in Canada, and which is currently working in on the same front. So to that question, my answer would be, you don't have a single system or a prediction algorithm which gives you 100%. Hello. Okay. I'll be
Thank you,
mute.
sir. ಈ ಮುಗ್ದಂಗಾತು.
I've muted the individuals for the background noise. Sorry. So with respect to the prediction algorithms, there is no single solution, Sapna. So what we at the industry level we do is we design the complete pipeline. So that means if you are using the Yep. So I think when the Kaylee team is kind of muting off, so I'm also getting muted off, and that's why you had that lag earlier. So I observed this when it happened now. So coming back to the same question, so there is no single algorithm which predicts with 100% accuracy with the data set, because we tend to move up with overfitting problem, and there is no exact outbreak, delimiting markers. So that is the answer. So we have uh, things which are there on the pipeline, like you run it with set of variables on the classifiers, and then based on the feedback loop you take it to the next level, where you are basically taking your decisions on either decision tree or what is the next approach which you're going to do. So it basically depends on the data set which you are using, and the approach which is being applied. So that is the answer. Share the GitHub link. Okay, so for the GitHub link, I think you can Google for Kaggle COVID-19 dataset. So it is already available, and there was already competitions which are taking off at Kaggle level. So if you are still interested on the live data set, or from where the GitHub links are getting pulled and how the exact data set is being used, uh, if you are still interested on AI front and the complete algorithmic part, you can follow this guy called as Abhishek Thakur. So he's the world's first 4x grandmaster in Kaggle. So either that is with your implementation, with your idea approach, with your model implementation and your test results. So he's the individual who is on top of the complete Kaggle competition right now. So what basically they do is they have a collaborative data set when they invite data scientists to use the existing data set and come up with their own models which can give you the exact adaptive results and which can be used and further advanced and taken to a next production level or to for the betterment of the world. So that is what they are doing in. And if you are interested, you can go ahead and use that. And most of you guys, I think, who are having a little flavor of ML and AI will be aware of Andrew Ng's Coursera course. So that's also a good source where you can start with the basic concepts. And the other one is with Data Camp, where you can initiate the starting part of your machine learning front, and you'll get the complete basics of how the exact things can be done in. So how to collect the live data set. So Swati, coming to the live data set, we are basically depending in on the data which is actually fed by different countries and which is kind of collected by larger organizations which have the monetary abilities to do it. So in terms of India, I think we have the government's website where we track the total number of cases and the other stuff. So the instructions are that all the healthcare related workers and the district heads, say for example of Bangalore or Hassan or any part of Karnataka, are responsible to upload the active cases which are there in that particular district. And that is how the whole state tally is done. And who are the individuals who are under quarantine who are tested positive, that is your active cases. And individuals who are being treated in hospitals and you know once they have recovered, that is your recovered number. And the death rate which we have, it is from individuals who are tested positive and who have died and who have passed away. And the death numbers can be little lower from my perspective as well, because India is not testing all the individuals who have died of natural causes as well. So say for example a person in Bangalore dies off from a natural cause, and like a heart attack or from acute breathing disorder where he was not diagnosed with COVID-19, but people around him thought that he is suffering due to old age, and his body was cremated and it was done with. So you're losing number on that front as well, because in India we don't have mandatory rules that after an individual is dead or anything, you need to have a post-mortem or you need to have certain sets of tests to be done. So we don't have those kind of stringent rules. So that might be one of the other reasons why we have low number of deaths. So coming on to live data, so this is kind of fed in by the authoritative individuals who are responsible for individual districts. And I think we can trust this data with at least 70% accuracy or at least 80% accuracy. So that's what I would say. I see nice session, good session. I don't see much of the question. Okay. Prima facie, this AI and IoT are looking at completely SNT issues, but ultimately it is being utilized for betterment of society. Yeah. So on the betterment of society front, yeah, I completely agree, because we are in a era where we need to feed lot of mouths because the population of the world is increasing. And coming back with the same old traditions which a farmer used to follow, so we cannot say that we will be doing the same thing which our forefathers did, because the needs are changing, the rules of the game is changing, and we need to adapt ourselves to the existing system which we are dealing up with. So any kind of technical advancement or betterment of the existing implemented solution is always valuable and it is advisable. So there are farmers in Mandya who are using drones to spray on a larger kind of pesticides on a larger area of data is also collected from drones. So this is actually happening because of lack of skilled labor in agricultural field. So uh, instead of hitting a dead end and saying that I'm not getting enough resources, it all fields they are going out and reaching out to the alternatives which are available, and what are the different aspects which they can think of to come out from that situation. So as they say, when you're pushed against the wall, you fight back. So once you actually get hit on your bread and butter, so everyone will, jump back on the same thing. So that's the approach, which I would say. uh, Let me scan for other questions. How can we use IoT device to fight with this COVID-19 situation with algorithms we can use? Yeah. So Swati, coming on to that particular question. So there was another GitHub project which was done in collaboration. So we have the social distancing norms and the other stuff, right? So with CCTV cameras which are present from the government side, say at a traffic junction or at a, at a sensitive place in Bangalore. So we can incorporate the video feed which is coming from the cameras onto a facial recognition system or an object detection system, to be exact. And you can set a minimum difference of 6 feet. So every individual or the object, which we can call, detected in the video feed should have at least 6 meter virtual distance from one individual to another. So what that actually helps us to do is, we are having the video stream coming and we are analyzing the live data from the video streams. So in countries like US, so this is already implemented with the traffic signals. So whenever a vehicle actually crosses the traffic violation and causes a traffic violation, the cameras which are installed will read the license plate and a case will be registered against them. So in India, however, the things are being implemented at a different level. There are individuals who are actually analyzing and making a note of the vehicle number, and that is how the cases and the other stuff are being filed. So we are not reached to that level because we are not getting proper funding for researchers, and the ideas are not being honored. So that's the first part. And I think that answers to a brief part of how the IoT devices can be used to fight against COVID. So that is one of the things. And in my PPT, I think I have mentioned about the drone with speakers. So in China, especially in Beijing, so what they are doing is they have incorporated this object detection into the drone itself, because the amount of task which it does is fairly limited. It does object detection, and the distance between one object or individual to another individual is lesser than 6 meters. It plays the same message that please maintain social distancing. And even after repeated announcements, if the individuals are not doing, then a photo of the individuals and their uh, details are being shipped off to the government authorities. For a country like India to implement it at that level, it would take years. It would take years, I would say. So check in any precautions while collecting categorical data through Google Forms. So, so Veena, I think when you're collecting any kind of data, uh, when you're doing it over the Google Forms, there will always be individual biases. So this is the initial part of your data collection, where you will have uh, the factors which will pitch in, like what is the individual's response, or what is his experience with that particular thing. Say for example, in this particular session, few of the individuals might have thought that they will have a look at the code and how the clusters are implemented. So they are on the disappointed front because the session did not contain that. So the form will always be containing those kind of negative feedback. So when you're having a collaborative data set, so what you can do is you can have a minimum bias ratio. So either you can use the existing algorithms, or the data collection front itself, when you're dealing up with larger data sets, say from around 10,000 to 12,000 individuals, then any kind of smaller bias which you actually mentioned, like vague responses coming, or mandatory fields not being filled. I think in Google Forms you cannot skip the mandatory fields because the submit button won't be available. But in case of normal data set which is collected for the models to be trained, you need to take care of the different outliers which you have. You need to take care of the different null values or the null pointers which are present in the data set. So to avoid that, you can have mandatory fields. You can basically have not null parameters for from the database side, where the data which is being written onto your database is in itself will contain some of the other values. So yep, I think that was it from my side, guys. So I'll be kind of sharing in the PPTs with the team, and they will be able to give it up to you. So thanks for being a wonderful audience, and I'm just dropping in my email address. So if you have any kind of discussions or doubts, you can feel free to ping me up, um, and I'll be available. I'm posting it to everyone, and feel free to reach out to me over LinkedIn as well. And probably if you want another interaction, or if you have some kind of ideas which can be dealt with, so we will be happy to discuss on that. And always remember, we need to kind of keep on learning and keep this whole journey going on, and happy learning. So that's what I would say basically. So ma'am, you had anything else to say? Hello. Uh, do we have anyone from the KLE side? I think I'm finished in. So are we expected to have a feedback form or something of that sort? Okay. Yep. I've dropped in my LinkedIn profile, so you can feel free to add me up and have a discussion. I'll be happy to do it. My areas of expertise are on the big data front, how we use Hadoop, and how we are using Hadoop as a tool to churn larger amount of data, and how we can design multiple pipelines which help us to analyze and churn the data. So yep, with that, I think I am closing in. So anyone from the KLE side, you guys
Akash,
have, yeah.
Akash, thank you so much. And there's no question from my end. I guess I should thank you for such a wonderful, informative session. And we did get a very good feedback right from the chats what we are addressing, as well as the YouTube live where we are going. We have a wonderful chats, and all I have collectively mentioned that it was indeed a very wonderful and informative session. Thank you so much, Akash. And participants, thank you so much for your patience listening and such a wonderful questions. Tomorrow's session link would be posted across into the WhatsApp link in WhatsApp group. Kindly join us 5 minutes before the 11 uh, so that we can have a very informative session on IoT as well. Thank you, Akash. Thank you so
Yep.
much.
Yeah, thanks, ma'am. Thanks for providing in this platform and the opportunity to have an interaction with individuals. And kind of sorry for running over by 15 minutes. So I was just a little involved with the questions which are coming in. So yeah, I'll be sharing up
It's
the
absolutely
PPTs.
fine. It is
Yeah.
absolutely fine. Participants, Akash has shared his GPay link, and I guess he's very prompt in answering all the questions that are being posted across to him. So please kindly, make optimum use of the information and the knowledge database that we are having in the form of Akash. Um, Anything else, please let us know through the group, and feedback will be communicated to you all at the earliest.
Yep.
Thank you. Thank you.
Thanks, guys. Thanks, and have a great day, and stay safe. And remember, we are all in this fight, and yep, keep the things going.
Thank you.
Thank you.
Thank you.
Thanks, guys.